Okay, so now it's recorded. Okay, so this is our course. Okay, SEU2073. So chapter 1 is introduction to signal and system part 1. Okay, so this is my name. Okay, so senior lecturer, I think, yes, this one, everyone is there. Okay, so then okay, so what is system? Okay, signal is a process. Signal process can either modify the signal or extract further information from the received signal. So in other words, it is a generator of signal or it is a transformer. Okay, just now I mentioned transformer, right? Transformer of signal. So it's not transformer the component for electrical power. It's transformer is in the sense that we might do some changes to the received signal or to our inputs. Okay, that we're going to have some outputs. Output can be the same as input or the totally different from the input. Depends on the transformer. So example, human body, radio receiver, or software algorithm. Human body is also a system. System is not is not only applies to electronically. System is a general word. So that's why we use here human body. So a system can have one or multiple inputs or port and one or multiple output ports. So a system have at least one input and have at least one output, but it can have many inputs and it can have many outputs. Okay, so here is a system input output of signal. Then you have electric circuits, which is your voltage and come out as current, for example. Okay, if you guys don't understand, just interrupt me. Okay, no problem. Okay, so the first lectures is a bit more like reading. Okay, but later on I think you get more excited because it will involve calculation. Okay, because we engineers, okay, we are deals with calculation equations. Okay, not so much preference on memorizing. Okay, so this course is about signal and the processing by system. So it involves the modeling of physical signals by mathematical function, modeling of physical system by mathematical equation. Okay, there is difference here. You see function and equation, and solution of the equation when excited by the functions. Okay, so please stay focused because I may pick names. If you are not responding, means you are not in my class. Means you are maybe if you want to go to toilet, you guys can just say toilet in, toilet out. Okay, don't be embarrassed. It's okay. We are adults. Okay, I just want to see if you are in the class or not. Okay, you just mention like this. Okay. So why we need study signals and system? I was asking you guys why we need to study it. Okay, so all of you have your own way of describing, which is good. I don't ask you to copy paste from books. Okay, I just want to know your own words. Why we need to study this? Okay, so why we need to study signal system? It is fundamental to all engineering. Okay, so it is fundamental. Everything have input, output, and transformer. So system. So step involved in engineering are model the system, which will involve writing a mathematical description of inputs and output signal. Okay, analyze system, study of the various signal associated with the system. Design system require deciding a suitable system architecture as well as finding suitable system parameters. So when we are involved in design as an engineer, okay, we need to make decision whether this parameter is accepted for our system or whether it is not. So here engineers come in to make decision. Maybe robots cannot do that. So that's why we need engineers. So when we have some parameters obtained from some function or whatsoever, so we will decide whether this is suitable for design or whether or not the system is working optimally or not. Okay. Okay. Implement system, test system, check system, and the input and output signal to see the performance is satisfactory. Okay. So, okay. So what is signals? Just now is signal system, right? What is signal? Signal are represented as function of one or more independent variable. It is something that represent information. Okay. Our world is full of signal, both natural and man-made. Okay. So we have signals that is man-made or natural. What you understand maybe man-made signal. So what is the natural signal? Nur Shamimi, do you know what is the natural signal? Nur Shamimi, do you know? Do you know what is the natural signal? Can you share to the class?
I don't know.
What do you think?
I
You know?
can't
What do
think.
you think that you can guess? What is the? Because normally we know man-made kan, but normally we know man-made, but we don't know the natural signal. Just guess. Do you tahu tak? Maybe I
I
would
don't
say,
know.
huh?
I don't know.
Ah,
I can't thinking.
ah. So I can ask this in my quiz. Student don't know. So you don't know? Tak tahu?
Tak.
Siapa lagi? Ilya, what is the natural signal? Man-made semua boleh
Don't know,
jawab.
sir.
Ha?
I don't know.
Tak tahu.
Tak.
Doctor,
You guys,
earthquake,
yes, Tukis?
earthquake signal.
Sorry?
Earthquake signal.
Yes, earthquake. Okay, this is a signals. Okay, good. Thank you. Anyone? Neuron in human body? Yes, it's signal.
Doctor,
Neurotransmitter.
like high body temperature, it's a signal for sickness.
Or that is the perception. Okay, but it's good. Thank you. Perception means when we see hot, there is a signaling someone is sick, right? Neuron is yes, is thank you, Ohun. Okay, don't you just interrupt me, you guys, using audio, okay? Because I cannot read Google Chat all the time. One Siti Khadijah is correct. Neuron in human body, correct? Because neuron is electrical signal actually, electrical something like that. Okay. And then what is our speech? Yes, our speech, because our speech is audio signal. Okay, our speech is audio signal. Now you guys know, right? So actually, natural signal is a lot. Okay, you just but you know that thing, but you didn't exactly know that it is a signal. Speech is also signal. Okay, you are giving signal. You speak with me just now is signal, audio signal. Okay, thank you. But of course, normally natural signal is analog. Okay, normally is analog. Example, temperature. Okay, designated is particular room. Okay, temperature. Oh, sorry, Ohud. Just now you say temperature, right? Is correct. I'm imagining like someone having fever, then someone put the hand on the head. Sorry. Temperature is also signal. Sorry. I was imagining different things. Okay. Example,
Doctor.
vibrations of rectangular. Okay. More example. Okay. Baby crying, value of stock market. Okay. Human voice. Okay. So what is a system then? System is a signal that process either modify or the signal or extract further information. Okay, this one is already been explained. Okay, now we see two types. Then we see types of signals. Okay, we have a continuous time and discrete time signal. Then we have analog and digital signal. We have energy and power signal. Okay, signal can be either energy or power or neither. Okay, deterministic and probabilistic signal. Okay, deterministic is that something that can be known, can be determined, and probabilistic is sometimes it's like random in nature. Okay, then we have harmonic signal. What is harmonics? Harmonics is actually repeated signals. Okay, that's why we call it as harmonic. Then we have even and odd signal. You guys will learn this with means that it is either odd or either symmetrical or non-symmetrical. Okay, so here we continuous okay, continuous time signals, okay, defined for all values of time t. Continuous, I think, is very understandable from the words. So you have continuous flow of time elements, okay. So you have 0 0.1, 0 0.2, 0 0.3, 0 0.5, and so on. Continuous. So that's why it's continuous time signals. Okay. For example, telephone outputs and video camera. Okay. Then we have another one is a discrete time signal. By the word itself, already self-explanatory, which we have only signal at certain time only. It is not continuous. Okay. So this is discrete time. Okay. Okay, then the analog and digital signals. Signal with amplitude which can take any value in a continuous range. This is analog, okay, which is amplitude is varies, but it is continuous. Okay, so amplitude of analog signal can be of infinite value. Okay, can be infinite, can be very, very high. Okay, then digital signals or can be very low, because you see infinity we can have positive and minus, right? Okay, digital signal can have amplitude with certain value only. This is where you learn from the previous course, okay, which is the apa nama I teach this last semester, lupa pula saya. Electronic digit, okay, digital electronics, okay. So this is digital signals, okay. We have certain value. Why? Because we sampling it. For example, if this value is above 10 volt, it should be regarded as 1, and lower than it should be regarded as 0. So we have only 1 0 1 0. Okay. Then amplitude of digital signal take value from a discrete set. Okay, this one is none. Just now I told you 10 volt or 0 volt. Okay, something like that. So this is example. You need to able to know the difference. Okay, when the question asks you, where is it analog or digital, and is it discrete or is it continuous, something like that. For example, for A, we can see it is analog. Okay, why analog? Because you see it has a very various range of amplitude, various values, and at the same time it is time continuous. Okay, so we have all signal, we have all value for all time. Okay, I mean for all continuous time range. Then B is digital signal. You can see, right? We have only certain value. For example, here, maybe this one is 3, maybe this one is -3. And at the same time, it is time continuous because we have all the signal in a continuous time range. Okay. Next is analog signal, but also can be a time discrete, not necessarily time continuous. So you can see we have here, it is analog, but the value of the signal is only at certain time, not all the within the continuous time. Okay. Then the next is digital signal and time discrete. So we have digital signal here. Why? Because it's only have certain value, like for example 3, -3. Then it is a time discrete because it is not continuous in time. Okay. Next, we go to this power and energy signal. Okay. So far, so good. You can so far so good. You can reply at Google Chat. So far, okay, okay or not okay? Only Obadah say yeah, fine, okay, okay, okay. You guys need to respond because if I am too fast, maybe some of you guys don't understand. But don't be shy. Just ask question. Okay, that's why I'm here. Okay. Then, okay, thank you. Okay, power. Now we go to the next one is power and energy signals. So you have energy signals, then we have power signals. Okay. So energy signal can be energy, power, or neither. Okay. So we have here, what is energy signal? They are definitely signal which has certain value of energy. So what is energy? Energy is actually measurement strength of a signal. Okay. Like we can say Wi-Fi energy. Okay, energy is the area under the squared signals. Okay, we have here EF, energy F. Then we have integration of infinity to negative infinity. Then we have squared of function dt. Okay, so some of you may ask or wondering why we have squared. Okay, why we have squared? Why we don't just use ft? Okay, because if we have a signals, okay, it can have a negative value. Okay, it can have negative value. For example, here this one has been squared. Okay, but let's say if we have negative value, the original dapat conting di sini. Okay, so let's say we have yes. So let's say we have signals, okay, something like this, okay. So we have some region which is positive, some region which is negative, okay. Am I correct? So if we didn't square it, okay, end up this one will be cancelled out. End up all of them, the energy will be cancelled out because one of positive, one is negative. So if we do the squared, all of them will be like positive, okay, something like that. Understand? Is it okay? You may respond to Google Chat. Now understand why we're using squared, not
Yeah.
using okay, thank you. Okay. Okay, continue. We're just now. Okay, so that's why we have squared. Okay. So power signal is certain signal which certain value of power and non-zero. Okay, it is non-zero, and power is a time average. Okay, is a time average. You see the word here, time average of energy means energy per unit time. You see the here and here is a bit similar. Okay, a bit. Okay, a bit. I didn't say it's totally look alike. It's a bit similar. Okay, and then it's a time average. Mean when we say a time average, mean the over time. That's why you have over times here. 1 over t. Okay, and complete period is t over 2 or negative t, because you can have one at the negative side here and you can have one at the positive side. Okay, power is useful when energy signals go to infinity. So example, periodic signal or random signals. Okay, so this is power signals. So it can be in the power signal or energy signals. Okay, so note that power is time average factor of energy. Okay, just now, right, is a time average. That's why it's 1 over t. Okay. Okay, it's a time average. This one is a squared signal. Okay, I just use this to make you guys, you guys don't, it will be like a focus to you. Okay, so I save first. Oh, ini memang dah save. Okay. Okay, where were I? Okay. So energy signal has certain finite value, okay, which is finite and has zero value of powers. Power signal has certain value of power and has infinite value of energy. Okay. In general, signal that has certain value in time from negative infinity to positive infinity has infinitive energy. A signal cannot possess both properties of energy and power simultaneously. Some signal can be classified neither as power signal or energy. Example, REM signal. Okay, Example, RAM signal. RAM signal is okay. RAM signal. Okay. So it is neither energy signal or neither power signal. Okay, so this is RAM signal. Okay. Okay, so periodic signal is also known as harmonics. Is repeated signals. Okay, repeated means you see here is repeating three triangles. Here is repeating how many repeatings. And then condition for periodic signal for any value of positive t. Okay, ft and ft plus t, ft plus nt. This one is to show repetition. Okay, so you have t as you have t as the time element in the time domain, and you have a value of t. Okay, so minimum value for t is known as the fundamental period t naught. Okay, fundamental period is means the most basic one is t naught. Okay, what is the fundamental? F naught 1 over t naught. Okay, hertz, the minimum lah, the minimum t lah. So you have f naught. Okay, then you have omega. Omega is actually this 2 pi f naught, then actually 2 pi over t naught. Okay, so this is the the value with minimum t is actually our fundamental period, and we label them as t naught. So we have this here is a periodic signal. You can see one complete cycle, we have one period t naught. Here is t naught. Okay, and this is a periodic signal, and this one is a periodic, means it doesn't have periods. Okay, it doesn't repeat it. Okay, so deterministic signals, okay, signal with a known. Okay, we can predict, and it is known. Okay, so can be described by analytical expression for all times. Okay, we can know the past, present, and future value. Okay, for example, just for example, okay, this is just for example. Okay, just so that you guys can understand it very easily. Okay, for example here, this one is harmonics. Okay, so this one is t value. Okay, so the past, let's say we take negative as past, value in the past long ago is negative. For not not the current future and not the current present. Okay, present maybe, for example, if you want t0. Okay, so because this is periodic, because this is deterministic signal, you can know the past, present, and also the future. Okay, something like that. Okay, is it understand? This is considered, for example, as past, for example. Okay, so that to make you easy understand. Okay, is it okay? Is it okay? You guys can respond in Google Chat. I don't want to go to first. You guys can respond in Google Chat, okay, when I say Google Chat. Okay, so that's why we have deterministic signal. Okay, you can determine that. The probabilistic signal, okay, thank you for the response. Okay, has only probabilistic representation. Okay, it is random. For example, noise. Okay, noise you cannot predict, right? Because noise kan, kadang-kadang ada bunyi, kadang-kadang tak ada. Noise can sometimes, like contoh right now, tak ada right now is peaceful, right, with my voice. I mean, you guys can hear, you guys can listen to my voice very clearly. But later on, let's say there is someone doing renovation, so there is additional sound, but I cannot control it, but it is there. So this is a noise. Okay, so that's why it's random, and that's why it's random. It can happen at any time, cannot be predicted. Okay. So has only probabilistic representation, which is a mean value, root mean square, etc. Okay. However, deterministic, we can represent them in mathematical and graphical form. Okay. So then we go to the next one is even and odd signal. So you have even, which is symmetrical signal. Then we have odd signal, which is anti-symmetric. Okay, at this stage, I think it is easy to understand. Okay, so even the graph is figure is easy to understand. So symmetric signal has the same value at time t and negative t for all value of t. For example, for this graph, for example, they say here is 1 second and here is negative 1 second, and let's say here amplitude is 1. You see here has the same value at time t and negative t for all value of t. So at t equals to 1, the amplitude is 1, the ft is 1, and at t negative 1, the ft is equals to 1 as well. Okay, so even though it's symmetric because you can see we can have the same value. So you can see, right, even signal is actually as if you can put the mirror in the middle. Okay, so symmetry at vertical axis. Now we have odd anti-symmetric signals. Okay, so the value of odd signal at time t is negative to the value at time t negative t. So is negative. So for example, if you have here is t equals to 1 and here you have t equals to 1. However, at t1 here, the f is 1, here is negative 1. So it is anti-symmetric. So here, that's why you have ft and you have negative of it. Okay. So if it's here is 0.5, this one will be negative 0.5. Then we have skew and hidden odd signal. Okay, hidden. Okay, the word later on. Okay, skew signal can also be skewed symmetry if ft negative f t plus minus t over 2. Okay, this is the period, and you see there is some then we have a negative here. Okay, we have negative here for any value of t. So you guys can see from the diagram. Okay, you guys can see from the diagram. So you see here it is a negative. Okay, so here you can see the, if this is one is positive, this one is negative. Okay, this is the skew symmetry. Okay, hidden odd signal is odd signal combined with DC value. Okay, it is not anti-symmetry anymore at horizontal axis due to upper or lower shift from the horizontal axis depending on the DC value. Okay. So what does it mean by hidden odd signal? Okay, let's say initially, where's my pen? Okay. Let's say we have initially signal like this. Let's say it is equal. Okay, let's say here is 3. Here is negative 3. Okay. Sorry, negative 3. Okay. So it is okay. Sorry. The key. I want to make it as same as this one so that easy for you to refer to the slide. Okay, macam ni how is it? Okay, okay, macam ni. Okay. I want to make it as similar as the one in the slide. Okay, the slide is Okay, so ignore this one, okay, because I want for it to look like the same as in the slide, so easy for you to refer back. Okay, like this. Okay, I just drew some, okay. So let's say this one is 3 and this one is -3. Okay, so what is hidden off signal is that we add some DC value. DC value is actually just like a straight value. Okay, for example here DC value. Okay, horizontal, we introduce to this signal. So this signal will be increased upward or downwards. Okay, please focus to my word. Will be shifted upward or downward. Okay, for example, let's say this is 3. Okay, so we introduce to the DC value. So this, what we refer as hidden signal, is that when it's actually carried upward. Okay, so here, so now it will be like this. Okay, so here 3 plus 3, this one is 6. So this one is 0. Okay, so understand? Okay, is it okay?
Yes, doctor.
Okay, where were we? Okay, so any other questions? I think I will cover the next one in the recorded. Any question? We will cover this one. We will cover this one in my recorded lecture for tomorrow, because you guys know tomorrow is holiday. Any of
Yes.
you know, because it's Prophet Muhammad birthday, Maulidur Rasul, right? Do you guys know this or not?
Yeah, doctor. Yeah, we know.
Ah,
Yes, doctor. Yeah.
those Muslim, don't tell me you don't know.
Yeah, we know.
So that's why I cannot take attendance, and then that's why I want to make it recorded lecture. Okay, is it okay for you guys? I will take recorded lecture. You guys will watch that, and also tutorial I will give. Okay.
Okay,
So
Okay, doctor.
and then
Okay,
do you guys okay? Do you guys agree that I will carry on our lecture in mix? Okay, some live lecture, some asynchronous lecture. Is it? I hope it's okay, right?
fine, doctor.
Yeah, that's fine.
Yeah,
Okay,
it's okay.
yes.
Because I want to consider students. I'm also human, and I also understand you guys don't. You guys not only study my course. Okay, so I just want to to have some understanding towards you. Okay, so some lecture will be live like this and recorded, and some will be asynchronous. Okay, and then I want to make it consistent of recorded for this second lecture. Why? Because your class is holiday tomorrow, but section 4, they are not holiday for this second lecture. So that's why I want to make it consistent. So section 3 and section 4 will share the same recorded lecture. And Adi, please take this schedule of mine. Okay. Wait, I show you. You can snap later on. Okay. Do you see this schedule, Adi?
yes, doctor.
Okay. You can discuss with your friend which day they, because I don't want, I try avoid 8 a.m. class. Okay, this is my schedule. Okay, you can discuss with your friend even in the WhatsApp group, don't worry. Okay, even in the WhatsApp group, our WhatsApp group, don't worry. Okay, so please, if it's possible to change this class, okay, this class to any other day that I am, you see free slot here. Just I don't want on Sunday. Okay, is it okay? Is
Okay,
it clear?
doctor.
Okay.
Yes.
So change. Even this one, if you want to change to be here, to be 9 until 10 is also okay. Okay. So I don't want you guys to work at 8 a.m. I also didn't really like 8 a.m. class. Okay. So dah screenshot tak?
Dah.
Okay. And my limit is until 8 until 6 p.m. Okay. So we can have class until 6 p.m. But normally I'm understanding, I think Adi and the rest know this, we don't really finish at 6. We will finish a bit early. Okay. So, okay. So thank you. Thank you for joining the class. See you guys next week. But please remember, I will share the recorded lecture. I will share the tutorial. Okay. Please do the exercise in the tutorial. And I will from time to time remind you guys, maybe you guys need to do some responding at forum or something like that. I will upload the tutorial at the forum. Okay. Anything I will update the class later on. Okay. So hopefully Adi, within this week, you can manage with your friend. Okay, you can ask them, don't worry, you can ask them. And then I hopefully the next week we will start with new schedule. We will not start at 8 a.m. Okay. Okay, thank you. You guys may leave and I will share the recorded lecture later on. Okay, thank you.
Thank you, doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you, Doctor.